Hello and welcome to the AI for Good all year, always online. My name is Xenia Fontaine from the ITU, the International Telecommunication Union, and I have the privilege of introducing today's session, Can AI and Digital Tech Accelerate the Energy Transition? Organized in partnership with Shell, AI for Good Gold sponsor. Now, the ITU is the United Nations Specialized Agency for Information and Communication Technologies. And we are also the organizers of AI for Good in partnership with 38 UN sister agencies and co-convened with Switzerland. AI for Good is a year-round digital platform where AI innovators and problem owners learn, build, and connect to identify practical AI solutions to advance the UN Sustainable Development Goals. And today, we are particularly counting on your participation to create a very engaging discussion. For this, we will be using the Q&A functionality, which you can find just left of center at the bottom of your screen. Additionally, there is a chat functionality, which you can use to have discussions with all participants. Please make sure that you send your message to everyone, panelists and participants. And I have the first challenge for you. Could you please let us know which country or city you are calling from? And let me write it down. So I'm calling from Geneva. So we have participants from India, Spain, Malaysia. It's going very quickly. We have a really international audience today. And with that, I think now it's time for me to hand it over to our moderator, Amy Challen. She's the General Manager for Artificial Intelligence at Shell. Amy, welcome, and your show is yours.
Thank you, Tina. And great to be here today. Thank you, everyone, for joining. As Tina said, I'm the GM for Artificial Intelligence, and my role involves thinking about this question in some form or another every day. So can AI and digital tech accelerate the energy transition? And our topic is clearly a really important one. The energy transition is one of the biggest challenges facing humanity today. I don't think any of us would debate that. And there's a lot of discussion around how such a fundamental change in the way we live and work can be delivered quickly enough to make a difference. So I'm delighted to be able to welcome a panel of CEOs, CTOs and researchers, and all of them are actually entrepreneurs as well, who are not just part of the debate, but are on the front line working to deliver the energy transition using AI and digital and other technologies as well. I'll ask the panel to introduce themselves in a moment, but first I wanted to just set some expectations, because I don't think any of us here would claim that artificial intelligence and digital technologies are really the solution to the energy transition. The solutions are going to be physical, chemical technologies, along with a profound shift in the way we do things. But I do believe that AI and digital will be really important enablers. What kind of thing? Well, a few areas whether they're really obviously very important can be through increasing the energy efficiency of everything we currently do. So in both production and consumption, AI is great at prediction and optimization, and these are already really well-established applications in all areas. And these improvements can be really substantial. If we can reduce energy demand, we can go some way to reducing our carbon footprint. A second area is enabling the integration of renewable energy sources into the grid. Load balancing is a major problem. The variation in supply of renewables is much greater than for fossil fuels, and this is a particular issue to solve. A third one is in monitoring ecosystems to track progress, see where intervention is needed, just understand where we're at a global level, so Earth monitoring. And finally, another area will be in speeding up the process of discovery for new materials, speeding up the R&D process. Traditionally, material discovery has taken a huge amount of experimentation, but if AI can speed up the time to development by predicting the characteristics of new materials and helping researchers quickly mine public sources of data, articles, any previous research for data and research findings, this can really help speed up discovery. So our panel today represents many of these different levers and approaches, all different parts of the puzzle to be solved in our transition to net zero. I'll ask them now to introduce themselves and tell us what they work on and why this is important. And please note again that you can ask questions at any time. by typing them into the chat, and we'll pick them up later in the session. There's a Q&A function or there's a chat. So please do get your questions in and we'll pick them up. So let's start with Ed Mitchard from Space Intelligence. So Ed, if you'd like to introduce yourself and tell us, why is Earth monitoring important and what do you use it for?
Sure. So I co-founded Space Intelligence in 2017. We're a company based in Edinburgh, and we use satellite data to map changes in the natural environment. So the world is being monitored by thousands of satellites, which are taking images using different types of technology everywhere on the planet every day. I don't think that data is being used that well, being used to its full potential to help fight the climate crisis. So we set up the company to use advanced artificial intelligence on these big data sets to look at how the forests and peatlands of the world are changing. In particular, we help projects that are trying to restore natural ecosystems that have been damaged, or that are trying to protect natural ecosystems from damage. So for example, we work in a project in Peru where there has been illegal logging and legal logging within a concession that has been taken over by someone who wants to stop that deforestation, not log it, and we track the carbon stored in those trees and monitor it to make sure that no further deforestation occurs. Another project we've done is mapping land cover in Scotland and its biodiversity, and we have a web tool that lets normal people in Scotland, normal users, as well as people actually trying to restore ecosystems, see how their landscape is changing and what that means for them in terms of biodiversity.
Thank you. So let's move on to Rajesh Solanki. Again, can you introduce yourself and tell us how Energos can help optimize energy consumption?
Thanks, Amy. Hello, everyone. My name is Rajesh Solanki. I am the co-founder and CEO of Energos. I'm a repeat entrepreneur with extensive experience in founding tech and cross-border businesses. What gets me going is to work on from an early stage in transformational opportunity. At Energos, we are building a unified software platform with Edge AI to help energy retailers to integrate all the different distributed energy and e-mobility assets that are coming up, and then serving new consumers in newer ways.
And do you have an example of that?
Well, so, one good example of a future energy retailer is the battery swap services. Battery swap stations are going to be microgrids, which have their own PV systems, their battery storage. They're going to be connected to the main grid, and they're going to have robotic infrastructure which can automate the swapping process. All of these equipment need to tie in into one data system. And if you have a chain of these battery swap stations, you have different makes and types, and you have to support different makes and types of electric vehicles. And that is a data challenge in itself. And AI has an extensive role in building efficiencies, optimizing, and creating differential services for future EV customers.
Thank you. Exciting example. And let's move on to David Boundy from Innovates. So Dave, can you tell us what the major challenges of renewables for the provision of electricity?
Yeah, hi Amy, and delighted to be here. Innovates, what we do is we are working with a variety of customers. Those are ostensibly energy retailers, network operators, and industrial and commercial users to unlock the potential that has been largely unlocked to date of the data that they have pertaining to their energy usage. So as many of us know, smart meters have been rolled out across the globe, and they're part of the solution. As Amy said, AI is not the solution, it's part of the solution. Building on another part of that solution, some of the physical world, the deployment of smart meters. There's a plethora of data that has been released or is now available, and we're using that data. We're analyzing it to identify where the flexibility is in the system, and providing actionable insights to our customers to be able to proactively manage to proactively plan and manage the energy consumption within their customer base, or within their, for example, buildings or commercial premises, to ensure that we can help drive the system towards net zero.
Thank you. And next we have Catherine Newman from Limejump. So again, Kat, do you want to introduce yourself and tell us how Limejump helps to manage supply and demand fluctuations that we've already just mentioned?
Hi, Amy. Afternoon, everybody. I'm Kat Newman. I've been in energy trading as such for over 20 years now. So now is the time to come and do something with the company. I'm now at Limejump. We are an energy tech company that's providing route to market and optimization services to the UK power grid. So in English, what this means is we buy power off renewable generators. We then sell that into the traded market and use our flexible assets, such as large grid scale batteries, to optimize the supply and demand on the grid. All very straightforward in principle.
You may be oversimplifying here. I'm sure it's much more complicated, but thank you for that. And finally, Umesh, could you introduce yourself and tell us how you use data and AI to speed up the R&D process?
Okay. Thanks, Amy. Greetings to everyone. I work at Jawaharlal Nehru Center for Advanced Scientific Research. I teach and do research with graduate students here. My institute is focused on materials and biology, the interdisciplinary areas of research. I was also a co-founder of a startup company called Breathe Applied Sciences Limited, which is engaged in conversion of carbon dioxide into methanol fuel. My research is on materials, which, as Amy said, are very critical to most technologies in terms of physically and chemically transforming the energy transition. And my work is based on theory and computer simulations to predict behavior of materials, leading to discovery of new materials which can be tried out in the lab. I'll give you 3 examples of works that belong to the problem of energy in the context of energy transition. One is the green fuel, where we develop materials which can absorb solar energy and split water to generate hydrogen, which is a green fuel. The second example is a green process, where we develop materials which catalyze conversion of carbon dioxide to methanol and chemically store hydrogen as a fuel. It's a green process as it recycles carbon. The third example is of thermoelectric materials, which convert waste heat generated in most applications into electricity using a material which are commonly available in copper mines in India. So this is, in some sense, these are green materials. The way we are using artificial intelligence or data-based approach in our work is, in materials, unfortunately, data is typically small with gaps, and most open databases are primarily computational, and hence, I would say, incomplete. So my efforts have been in developing schemes and algorithms that facilitate learning from small data sets, and accomplishing this using 2 approaches. One is to identify key minimal sets of features which are relevant to the technology. And second is use of physical laws to integrate with machine learning in developing simple models. Thank you.
Thank you very much, everyone, for the introductions. So one question actually I wanted to ask, hearing your intros, is the title of this was actually about AI and digital technologies. And we've mainly focused on AI so far. So one question I wanted to ask is, are there particular areas of the energy supply chain end to end that need digitization before we can engage with AI? And of course, the reason I'm asking this is these 2 are closely related. You can't do AI without data, and digitization is often the way we get data. So does anyone have any particular views around particular areas that we need to digitize quickly in order to be able to make good use of AI? I don't know, Catherine, if you had a view on that.
I think the big challenge, I think we all know with AI, is it's about the quantity and the quality of the data for us to actually do something productive, and it's a massive challenge. We've actually been talking about it quite a lot this week. For us to specifically talk about the UK here, but this can be related to I think to any market, is how do we as distributed energy, or as energy becomes more distributed, and we move to smaller and smaller assets across the customer base. So we're moving away from, obviously, we're very happy, we're moving away from coal power stations and things. We're moving to more offshore wind. We're moving to solar panels. We've got the flexible assets in that mix now. We've got all these grid scale batteries that are coming on, as well as going down to your lower level EVs, the stuff that's in your home, all those smart devices, to enable us to actually start to balance all of that, supply and demand on a real-time basis, right down to that very granular level. It's how we get access to all of that data. And a lot of that data is becoming more publicly available, but a lot of that data is held very privately because of the commercial value behind that. So it's, how we get access to that data, and, it's all kept with the same kind of metadata. It's all accessible to everybody. How we get to that is a huge part of that AI challenge. AI is, machine learning is completely impossible without access to that quantity and quality. So how we get to that point through, I think, legislation, government, the regulatory change is a very big challenge for all of us. If we're going to drive towards that 100% renewable targets that we all want to move towards, it's going to need a lot of cooperation.
Yeah. And what would that look like? Some kind of standard set of data standards, maybe, for the industry, so everyone could collect data in the same way and then share it anonymously?
Well, there are lots of different initiatives going on. I think David's probably got a good answer for this one. I can see him waiting to say something.
Yeah, so just as Kat said, obviously access to data is critical. As we all know, there's been an awful lot of work done around GDPR and the protection of everyone's data from a privacy standpoint, and that is key. Making sure that we've got the right controls and the right security and the right understanding, and ensuring that the owners, in essence, the end user of that data, or the end generator of that data, actually has the ability to control it. So first and foremost, I think the onus is on the businesses who want to use the data to have the right controls, the right security, the right compliance in place from that standpoint. Secondly is around, obviously, balanced regulation to make sure that that data is going to be made accessible, and that we think holistically about the value of that data from an overall good AI for good perspective, right? I mean, in terms of, we can't optimize the grid without having access to the data that tells us how it's operating in real time. That also applies to kind of the end usage of that data, as Kat mentioned, whether it's EVs or whatever it might be. It's not to say that the companies doing the optimization have to know where and when you're using your EV, but they need to have some kind of comprehension as to what's happening. There's a lot that can be done there through AI and through inference itself. But as I said, first and foremost, we need to make sure that there's appropriate controls and security in place, but getting access to the data is key.
Thank you. And I think, Ed, you've also spoken about the criticality of data to you. To what extent are you able to use public data versus having to acquire private data to do the kind of Earth monitoring?
Yeah, so I guess there's two different sides to this. So there's masses of free and open satellite data at the moment. That's kind of started with the Obama administration in 2009, made a great decision, in my view, to open up the Landsat archive, and the other space agencies have followed suit. And there's now loads of very high quality free and open data that you can use commercially, which is great. So we have this deluge of satellite data, but we have to make sense of that, turn that into information. And that often involves labeling, so data in the ground. That might be people going and sticking sticks into peat bogs to see how deep the peat is, or measuring the diameter and height of trees, or it could be simply as labeling something as a field or a grassland or a forest. Some work we've done in Brazil recently is around trying to automate some of that process to take advantage of the open pictures there are. There are billions of pictures on the internet that people have captured on mostly smartphones, and made open and available for anyone to use. We're hoping to develop some technology to use those photos to help label satellite data. You're kind of looking at things from two angles then. You've got the sideways looking detailed picture, and you can use artificial intelligence to decide what land cover type that is, and that will train your satellite-based AI to make maps of land cover in space. And we'd love people to help more with that as well, I guess. So something we're interested in is maybe an app or something to help target people to go and take photos of their local environment to help us interpret satellite data or track forest restoration happening, for example.
And that's because you need the interpretation of the data as well as the actual satellite data. Can you say a bit more about that?
Yeah, absolutely. So we look at every bit of the Earth several times a day. It's often cloudy and might not be the best technology, but we see every bit of the Earth hundreds of times a year. So we have loads of observations. That's lots of information. We can apply very fancy algorithms if we like to those big data sets, but you won't get anything sensible unless you have a parameter you've measured on the ground that you want to compare that to. So often that's the carbon stored in trees, or something about the land cover type. So is it agriculture or what type of crop of it? Is it forest, restoring forest? Is it a non-native conifer plantation? We need those labels from the ground to be able to plug into our dense set of Earth observation satellite data and create an output map that's useful to someone. So yes, that kind of labeling is vitally important, and that's a time-consuming part of it. And anyone who's worked in AI will know that a lot of the actual work is in having a good kind of label data set and cleaning up these data sets. It's not problematic to apply a complicated algorithm. It's not difficult to come up with big data sets, but getting high quality labels is vital, or it'll just be junk in, junk out. With satellite data in particular, we often don't need to run very complicated AI on our systems. We just need to be doing the right corrections to the satellite data and have good labels and deal with the big data problem. These satellites are collecting tens of terabytes of data a day. So we get very big data sets. We want to do consistent, nice, simple AI things to them with good labels to produce good output maps to help save the planet.
So it's something the general public can help with. Thank you. And just to shift gear a bit, I think I'd like to return to the issues we were talking about matching supply and demand when most of our energy is coming from renewables, not from fossil fuels. And I think one quote we've heard before is that perhaps we have to move from a demand-led system to a supply-led system. And so I don't know, David, if you wanted to comment on that, and what that might actually end up looking like.
Yeah, sure. I suppose just to reflect back on what do we mean by a demand-led system, which is where we're coming from. In essence, what it is as energy consumption has grown over the last century, we've just built more and more infrastructure. We put more coal-fired power plants in place, more gas, more oil, more nuclear, and we've put thicker cables, more transformers, more and more expensive grid. As we transition to renewables, what we see happening is that obviously renewables are available when they're available, right? It's very difficult to store energy. Yes, we can through hydro pumping, etc., and also through battery storage, as Kat's talked a little bit about earlier. But by and large, we're not going to be able to store all the energy that we generate from renewables and make them available at the times we need them. The pattern of the grid is, as many people will be familiar, as a duck-shaped curve. You have a peak in the morning, a lull in the middle of the day, and a peak in the evening. If you look at solar generation, it's pretty much the opposite. It generates during the day, and wind obviously has different times of the day when it's stronger. So how do we change our grid to be a supply-led grid? Is the key question. So first of all, we need to understand what's happening at a consumption side. We need to be able to plan around that. And then we also need to be able to control what's happening at a supply side. So in essence, it's about identifying where the load optionality is, or which loads can be moved to which times to match with the supply. And we recognize there's certain things that can't, but there is a lot of load that can actually be moved, whether it's heating or cooling of a home, or chilling in a business, or when an electric vehicle is charged. All of those different things can be managed in an intelligent way so that they can optimize and be aligned to the grid. But the burden of doing that on an individual to say, okay, I'm going to schedule when my heating comes on and when this happens, and I'm going to understand when the wind is blowing and when the solar is happening, it's not practical. It's never going to happen, right? I work in energy. Could I get anyone in my house to engage in energy? No, right? As long as it's automated, that's all good. And that's where we're trying to get to. That's where the opportunity lies.
Thank you. I think if I could make my heating work when I wanted it to, I'd already be happy, but let alone optimizing it. And what percentage of the solution do you think is going to be on the demand side versus on the supply side? Like how much of this kind of balancing do we need to go on both? I don't know if anyone has a view on that.
Yeah, I think that's I'll leave it open to others to answer. I think it's going to be difficult to give an exact percentage wise, but it is what we recognize is a combination of both. Obviously, as battery technology and large battery storage increases, that will provide us with more flexibility. We'll have obviously things like biogases, which will give us more of that flexible generation from that standpoint. Nuclear, what is the role that nuclear plays? So all of those factors will come in from a demand side, and then on the supply side, and then obviously on the demand side, there's going to be a level of flexibility. If we look as we go through the energy transition that we're going through today, or the conversion of transport and heat into energy based, they in themselves provide a degree of flexibility. If we're talking about large batteries, basically, that are electric vehicles, the timing on which they can be charged will vary. I know myself, we have 2 electric vehicles at home, and they're charged intelligently. So, yeah.
Yes, I'll just add to Dave's points. I think I don't think the analysis is really there on what the percentage split is right now, but I think the consensus is generally agreed that a huge amount of it has to come from the consumer. So as devices become more intelligent and also cheaper, one of the big things that we look at when we talk about trying to drive, towards that zero future that we all want is, at the moment, it's a real middle class problem when it comes to some, especially the intelligent management of stuff at home. Things have to become a lot cheaper overall for this to really be a solution. For the vast majority of the savings that we want to make, it has to be driven by the consumer as a whole across the globe. So a huge amount of it's going to come on the supply side, but that's going to be over time as things and costs of things start to come down. On the the generation side, obviously, we'll continue to build out the renewables mix across the various different countries. And there's one of the things we've been talking a lot about at the moment, and also on the regulatory side, is how do we balance supply and demand far more intelligently? Should we be moving to, we were talking earlier about what kind of data do we need to feed into AI and for the machine learning we want to put in place. One of the things we were talking about is if the UK is an example, because I predominantly work in that market, what if we move to more of a zonal pricing type system where we split, rather than the UK being entirely priced at one price, which is completely bonkers when you really think about how the renewables mix is now made up. Predominant amount of renewables are generated in the north and Scotland. The predominant amount of consumption is down in the south. If you actually move to zonal pricing, you'll suddenly get a pricing differential all over the place. It could be really cheap for your power up north because there's not as much use, but down in the south, it's far more expensive. So it may redistribute where generation is actually built. It may force some planning changes. It really start to force a localized balancing of that supply and demand, and it really may force some of these modernization and changes that we need to actually make that happen far quicker. So there are lots of different things happening at the moment, lots of great challenges that are going on, but I think it's too early to really say what percentage split it will be, but I think we really need to look at how we can drive some of this change quicker.
Thank you both. And I think I'd like to pick up on the batteries point a bit, because we mentioned a couple of different forms of essentially storage to allow this kind of flex. So we're not just dependent on when it happens to be sunny, when it happens to be windy. So I think batteries are a concern. Batteries are not in a state currently which can solve all our storage needs. So Umesh, from your research, how optimistic are you that batteries can be a large part of the answer? Or do you think that we just have to look at other options?
Yeah. So no, I do agree that batteries are very crucial, and more broadly, energy storage is very critical, the technology of energy storage. I already mentioned that there are ways of storing hydrogen, which is a green fuel, in a form which is mobile, usable, and other ways. But as far as batteries are concerned, let me say a few things. Particularly, materials are very critical to development of batteries which are efficient and cheap. Basically, having a long cycle life and fast charging, safety, these are desirable properties, and their materials can be very important. And if you look at the current use of machine learning in development of new materials for battery technologies, most of the databases are focused on very small component of a battery, like a cathode component, another anode, or electrolyte, which is used in a battery. So battery, on the other hand, is a very complex system, which is sort of an integrated device made up of all these small elements, and the interfaces between them, disorder between them, can introduce lots of complexities. And machine learning can be quite powerful in addressing those complex issues inside a battery, how things happen and how they can be made better. So the opportunity here is basically, again, we talked about data, and I'll touch that point again in the context of battery materials. There is a strong need to combine data which is available from experiment as well as computation. Yeah, and that's not a simple task. It will mean there's a need for cooperation between industry and academia, integration of machine learning and physics-based approaches of electrochemical models of batteries to develop robust techniques to sort of accelerate development of more efficient batteries, which are for mobile applications as well as grid-based solitary applications. So coming back to data, I think this point is a general point, not just for batteries. A question, see, materials is where I mentioned that data is small typically. And at the same time, you will know there are a huge number of scientific publications which do publish a lot of data on materials. And there are efforts in the United States where they use natural language processing techniques to extract digitally the data published in papers or patents and other types of documents available. My philosophy is, I think we can also rank data based on the impact that data has had, and that information is also available readily. For example, if there is a paper published in a journal, its impact is available in the form of metric of citations. And usually that impact is high when the data is very high quality, or more importantly, readily usable. Even negative data can be quite important for developing good models. So I think there are excellent opportunities for integration of data as well as development of reliable, good databases and use of machine learning in batteries.
So we'll see where we can go with that then. Great. And I think one thing actually that's come up in the questions and is a very common question asked about AI is, what's the environmental impact of actually doing AI in itself versus what benefits can it bring? And I think Tim Unwin has asked in particular, what's the impact of having a load of launching a load of satellites to get the Earth monitoring data? What's the impact of collecting all this data? Does anyone want to address that about the environmental impact of using all these technologies? And are they, well, maybe they have longer run benefit perhaps, but what's the environmental impact now? Ed?
Yes, it's certainly something we've thought about. So obviously, launching a satellite involves a massive burst of carbon, and then storing that data and running deep learning AI models again burns carbon with all these servers wearing away. I guess we've looked at our carbon footprint as a company in terms of those things, and our share of those satellite launches is so tiny, and our models are not huge in the grand scheme of huge, that probably our carbon emissions from that are less than our carbon emissions related to heating our office, for example. It does form part of our emissions as a company. And of course, we're trying to get to net zero, and we'll work on reducing those. There's code we run routinely which compares the carbon released from different options. So for example, you could have 2 or 3 different ways you might model biomass from a satellite data set, and you can choose the model that has the lowest carbon output. That might be related to the actual code or to which server you send it to. That's something we're keen to do to reduce our emissions. And many of these data centers now use renewable energy because it's the cheapest energy in many of the parts of the world where they are anyway. But yeah, it's something we need to be mindful of and work to reduce in general, and not run unnecessary code, run things on small bits. There's an easy win here, of course, because running code and big models costs a lot of money because you're doing a lot of computation, and that money also is what burns the carbon. So businesses should be sensible about what they do, and that will reduce the money they spend on AI processing as well as reducing their emissions.
Thank you. And if I could point that same question to Rajesh, because I mean, you and your company use some really quite advanced AI models, and this, as we know, can take up a lot of quite a lot of energy. So is this something you've dealt with?
Right. I think it's a great question. We believe that the role of federated AI is important in tying all this data in. So initially, I mean, if we end up looking at bringing all the data from distributed assets into on the remote side on cloud, then the amount of data on the remote cloud platforms is going to be very high. So you need a lot of data centers. But if you would bring in some data initially and then build learning models and deploy them on individual distributed assets and learn from those models and only transport learnings on the remote side, that would create a leaner and more agile digital model for the future energy transition. So, and federated, Amy, again, is a bit of an iterative process. So you need to get data first to be able to build any kind of learning model and deploy it on the edge. Second stage, you probably can build some AI algorithms on the edge and deploy those to build certain optimal actions, maybe build fuzzy logic and automation, maybe optimize things like heating and cooling loads. So that would be the second stage. And the third stage would be to really build federated learning models and deploy it on each of these loads and sources, and then bring only learning. One big advantage of that, I mean, other than that you need less data center storage capacity, the other big advantage would be that if these assets are owned by multiple retailers, one retailer could learn from the learnings of the other retailer without having to share data. So it would also take care of data privacy in a easier way.
So that sounds like we're going in a direction of sort of more shared information and almost shared data across organizations. How could we reconcile that with what is fundamentally a competitive market? Like, how could we get to something where we can collaborate without undermining sort of competition law?
Yeah, again, these are things at very early stage, but the possibilities are amazing. For example, if you look at how battery storage batteries are performing, and under what conditions, and how the frequency of storage or fast charging, slow charging, how it's going to behave and how it's affecting the health of batteries. Now, individual different usage patterns, if the AI is distributed, that learning can be faster. And then one usage pattern, there's a learned model. The learned model can be refined, and then that learning can be shared with where somewhere else it is that infrastructure is just being set. Also, with this kind of a architecture, you can integrate any type of loads and sources, right? So I think David mentioned that we have the possibility is that there's not just one solar or wind, it's also small nuclear, it's also hydrogen, it's all different types of energy sources coming up. And from a consumer point of view, the consumer deserves reliability and ease of access. And that will be better served if you distribute the intelligence and not have to always rely to port data on the remote side and then learn from it, because the learning will take a lot of time in that case. While as federated learning can learn faster at the distributed nodes.
So some helpful technological solutions as well. Thank you. So one question I think we've touched on a couple of times on the Earth monitoring piece, but is there any way the general public can participate in any of these schemes to promote energy efficiency? And I think, Ed, you mentioned about the need for people to basically provide photos, geotagged photos. What would you need there?
I guess that was an idea we haven't built up into a real tool yet, but there generally are some citizen science tools in most countries in the world now where you can go out and see what's biodiversity there is around you, take photos of butterflies and flowers and so on, and help catalog what's in the natural world. We were thinking of an extension to that to help with monitoring land cover and land cover change. And well, I suppose let us know in the chat if there's interested in that. That's something we might build. I know people are interested in their local environment. I mean, it's absolutely crazy the way this tends to work from a more scientific point of view at the moment. If I want to create a biomass map of an area, a traditional way would be for someone from the UK, a team, to fly out there and go and measure some trees and maybe train some local PhD students to do it next time. But there's a lot of carbon being spent doing that, and we don't know the local environment. It's much better. We have all these people around the world with this brilliant piece of technology that has GPS and phone in it. So many people have smartphones now. We should be taking advantage of those because they capture really rich spatial information on what's there at that point in time.
Okay. And David, I think you rely on customers, people and businesses actually be able to share their data in order to make an impact here. What could people do to make sure that they're able to fully participate in these schemes?
Yeah, obviously, I think the first point is make sure you're with a provider. If you're using an energy retailer, make sure you're with a provider who is proactively utilizing the data that they have today. They're providing services to you that help reduce your carbon, and then also make sure that you're actually sharing your information. If you get, like, so for example, in the UK, it's an opt-in basis to share your smart meter data. So you make sure you opt in. Now, I wouldn't say doing that blindly. Obviously, you need to trust the people you're providing your data to, etc. So always make sure that the people, the services that are providing you with it, have the relevant certifications. That may not necessarily be the easiest thing to do, but if you're with a supplier in a particular country, make sure it's a trusted supplier is the first thing I'd say. I think maybe if we just could step back a little bit as well and talk to the point around the carbon intensity and more the overall environmental impact of AI. I think there's a couple of key points that I'd like to address there, and I've seen a couple of comments and questions in relation to this. It's not just about carbon; it's about the broader environmental impact, be it from water, be it from the consumption of silicon and the impact that has on the environment. So I think first and foremost, any AI companies, like any respectable company, needs to look at their supply chain and understand how is their supply chain providing them with their services. In our instance, a large part of our supply chain is the data center. So how do they deal with electronic waste? How do they deal with recycling? Are they ensuring that there's optimization in the use of the compute in of itself? That's one thing that can be done. And if I take Innovates, what we do as an example, we make sure, number one, the data centers that we use are using 100% renewable energy. Second thing that we do, actually, I was going to say eat our own dog food, but drink our own champagne, in the sense that we optimize when our compute runs to ensure that it's running only at times when the grid has renewable energy. So not only are we ensuring that our suppliers have a direct contract for renewable energy, but we actually run our compute at times when we know the grid is at the lowest carbon intensity. Then we also need to make sure that, as I said, all the recycling and so on is taken care of. To the point that was mentioned around distribution of compute, yes, that can play a role, but we also need to look at the overall impact of that. So if you're using large data centers, there's the opportunity for that data center to be used for multiple different purposes. As I mentioned, we use compute at the time when the grid is at the lowest consumption. There may be other essential services other companies use, and we share that compute. So from an environmental perspective, we're reducing the burden. I think lastly to say, just in that regard, is that whilst data centers are putting pressure on the grid today, I know it's becoming a topical point, they can also be used to help ensure that renewables are being optimized on the grid, because most data centers will either have some sort of backup in terms of be it battery or self-generation, so they can come online when the grid is under pressure. So again, by making sure that we have the right supply chain, and that's up to the companies to make sure that they're doing that.
Thank you. And I'm just picking up a question from the audience here about the skill sets that will be needed for the new world, new energies enabled by AI. And I think that's a general point. This sounds like a world where everything's going to be automated. In response to sun or wind, we're going to automatically change prices, turn on, turn off different energy sources. Is that what it's going to look like? Or are there areas that we're never going to be able to automate and the people are always going to be involved in these kind of decision making? I don't know if Catherine, you had a view on that.
That's a hard question. Why do I get the hard questions? No, so yeah, at the moment, I think very much we're in a split. I don't think we're at the point where we can absolutely automate everything. That there's too much of the human side. There are companies that have differing views. Some companies that do very similar things to us are 100% automated. But in terms of our view right now, in terms of how the market works, I think you need that combination of the human intelligence that's got the trading experience on top of the machine learning you have in place to look at your generation forecasts, look at your weather forecasts, how you can improve them, how you can kind of use deep reinforcement learning to look around balancing the systems and start to build on some of those things. I think when we're looking at maintenance at the moment, when we're talking about maintenance of assets, currently that's a very manual thing that's done by a human. That is very much, you're moving over to things like predictive maintenance that you can automate that so you can build it into your models of supply and demand balancing. I think how you sort of look at the market conditions and trade as a whole, you can automate a lot of that, but it's I don't know if this is the right phrase, but it's that human augmented machine learning piece. I think that is the next step for when you're looking at how you can start to currently use a human to react to market conditions and changes. How can you start to really teach those pieces of machine learning you have to start to look at how the human reacts and learn from those? That's definitely some of the next steps that people like us and the rest of the market are starting to look at now. Whether I think 100% automation, I think we're quite a long way off that, because also it's the sensor issue. You need sensors to do lots of these different things, to look at how assets are running. It's not just we've got to get all the meters in place. We've got to be able to read the data. We need to be able to see what's going on. When you're looking at bigger schemes of how you predict sort of future scenarios of how CO2 distribution is going to work around the UK where large distribution is based, you definitely need things like AI for that. So you could be looking at, okay, there's a large industrial site here. We need lots more generation here. There's a huge CO2 output here. So how are we going to replace that old carbon energy need with something that's more renewables based? Definitely starting to do future scenario type planning using machine learning for that and AI for that. Absolutely. But whether we'll be 100%, I'm not fully bought into that myself yet. I think there's so much we can do, but it's baby steps. Let's just get there, but we'll get there slowly. I'm not sure I'm quite ready for 100% AI yet. So I'm happy. I'd love someone to counter me on that one if anyone has a counter.
No, everyone knows how hard it is. Yep, I always say AI is the easy bit. It's the process change, the people change, the rest of it, but it's actually really, really hard. So I think, yeah, I would agree we're a long way off. Hopefully we're away from spreadsheets, but not always, I think. One quick question on pricing. I think a couple of people mentioned sort of the possibility of using much more variation in prices to reflect what's going on. And Kat, you were mentioning sort of where the energy is coming from versus where it's being used and how we can do it. Could we have a system which had radically local pricing, where pricing changed from minute to minute, and we were asking consumers and industries to respond? Would that be feasible?
I'm happy to start on that one. I think it's really feasible. I think the big challenge is the regulatory change that comes with it. So we have a habit in the UK of consulting on everything. Continuously. And, that's great. We need to get input from experts in the industry and have conversations around it. But, for this kind of shift and change to happen as quickly as we want and to really drive down to those zero carbon targets that we're aiming for, we need to move quite quickly on things like this. So, zonal pricing is something that's been considered in the UK at the moment. It's very early stages. We were talking about how long do you think this would actually take to implement? And, for all the regulatory people I speak to, they're like, it's probably going to take about 10 years, given the speed at which government works. And I don't think that's a flippant remark. It probably will take about 10 years to get there. So if we really want to try and drive some of these very fundamental changes, enable ourselves to use machine learning for some of these activities of supply and generation balancing, from an automatic basis, we have to move to something like zonal pricing. It's definitely one of the favoured options that's on the table at the moment. But open to hear other people's views on that and ways we could possibly make it happen quicker.
Yeah, I'd agree with Kat in terms of ultimately we need to have more granular pricing, which will invoke a change in behavior. Now that can be supported by automation and AI that is automated with managing the devices, but we need to drive those investment decisions to enable the automation and the AI. So I think it's critical. And it's not just around the network contention, it's around the availability of renewable resources. So for example, today, there are times when there's negative pricing in the wholesale energy market. If that was transferred through to the end users, and that's driven by kind of the availability of renewables ostensibly driving that disruption, right? So if that was passed through, if that could be added through to the consumers, would that drive a change in behavior? I think you'd find it would.
Interesting perspective. I think the other side of that, of course, is just aspects like fuel poverty and the political nature of that, that if you happen to be living in an area which doesn't have much in the way of renewables nearby, it can be a very difficult choice to make, and it could seem to be unequal in other ways. But it's an interesting idea.
I know, I agree, Amy. It's a key point as well that there is a risk we create even greater fuel poverty as people become prosumers and more independent and less dependent on the network. And if you put in regional pricing in relation to congestion, et cetera, in the network, you could actually exacerbate an already bad problem. So we need to be careful on it. And I guess back to Kat's point, that's why you do need to consult with people.
Great, thank you. And I realize we're coming to time, so I'd like to invite each panelist one by one to answer final thought. What do you see as the biggest opportunities for AI in your space? If you had one wish to make it work, what would it be? And starting with Umesh.
So, Amy, the use of computer simulations in discovery and design of new materials is limited by the fact that predicted materials cannot be synthesized in a scalable way, whereas there is a strong need to have an integrated approach, which will use data from synthesis of a material to its structures at different scales, and then properties, and then performance. So to have an integrated model which will capture material behavior, which will be relevant to the industrially relevant applications, is a key problem. And machine learning has a huge role to play there, because machine learning doesn't care about the type of data in some sense. So it will be equally exploiting the data available at various stages in the research and development process. So there, I feel there's a huge role for machine learning to play.
Thank you. Rajesh.
Yeah, I'm excited by the possibilities behind the meter. As residential, commercial, industrial, all energy consumers, as they become prosumers, AI can do a lot to make their life easier and to give them newer choices, which they never knew they had. One example is if you have multiple sources like solar and battery and connected to the grid, and you want to charge your EV, you can have a choice of the source of electrons. So you can create autonomous energy flow through AI, and then people can have green electron, brown electron, black electron. So I am excited by these possibilities as future consumers become prosumers.
Brave New World. Great. David.
For me, where I'd like to see it is by, say, 2030, AI has had a measurable impact on global net zero targets. And ostensibly that will be enabled through access to the data by dealing with putting standards in place around the structure of that data, by having the capability to manage and clean that data. So, I think it's an exciting time coming forward. We're starting to see momentum building And I believe that AI can play a critical role between now, 2030 and beyond in that drive towards net zero.
It was about data. Great. Ed, what do you see as the biggest opportunities?
Well, I hope the governments carry on their work towards making more and more data open, and companies and consumers and others. So I've seen in my industry a massive explosion in companies and useful applications due to satellite data being largely opened up. But there's so much data that governments and companies hold that doesn't have much value to them, but they haven't made the effort or released it. So for example, things like the location of the field plots and the data from the national forest inventories from many countries that's held by governments, don't necessarily use that apart from providing reports every 5 years. That could be used to help make better biomass maps of the carbon storage. There's many data sets like that if they were opened, it would help, combined with AI, produce outputs that could help fight the climate crisis.
Thank you. And Catherine?
I think like everybody, we want more data, better standards across that space. But when it comes to how I hope, machine learning and the like will drive our industry forward and towards net zero, I really want to see, once we've got access to all that data right down to the household, as well as that grid level, offshore wind farm level, I really want to see machine learning pulling that all together and driving down power prices through optimizing the supply and demand balances across the UK as well as it can through an automated fashion. That's my dream. That's that virtual grid concept that we'd all love to see in place, because that will really start to push down the carbon that's put out into the environment. Really, with all the newer renewable technologies that are coming online, I think all of that balanced together using IA for the best, we could have a wonderful outcome that would hopefully get us to net zero quicker than 2050.
Thank you. And I echo the sentiments around the criticality of data. It's AI is the exciting bit, but you spend 80% of your time as a data scientist trying to find the data, cleaning the data, trying to set up the data, and it's the terrible reality of life as a data scientist. And that's even if you've got data. So I think that is a huge one. So I think the clear ask for consistent policies towards openness of data, towards sharing of data with appropriate anonymity and safeguards, and to share these technologies and data as we go forward to accelerate the transition. So thank you, everyone. So I'd like to say thank you very much to our panelists and to AI for Good for hosting this webinar and for the questions in the chat, some of which I hope we've gone some way to answer. Obviously, they're complex questions. There are no simple answers to any of this. I hope it's clear that there's a huge patchwork of different approaches to this question. How is AI going to help the energy transition? There's no silver bullet, there's no one answer. It takes a huge amount of different technology, a lot of data, as we said, and a lot of collaboration and coordination across different actors, governments, private companies, government and organizations. So thank you very much, everyone. I hope you enjoyed the session, and I hope you all have a fantastic rest of the day.
Thank you very much, Amy, for moderating this amazing event, and a big thanks to all our panelists for all your insights, and of course, Shell for curating this event. The recording will be available soon on our website. And now we would like to see how you, our participants, would be interested in recommending this AI for Good. So we are going to launch a quick poll that will now appear on your screen. And it has a smiley faces for easy reference. And in the meantime, I would like to highlight a few upcoming sessions. We invite to stay with us online. In 1 hour, we have another event starting, Transforce AI Through Law, Current Proposals to Regulate Artificial Intelligence. And next week, on the 30th of November, we have 2 events, one a hybrid event at 1 o'clock, the case for digital health, accelerating progress to achieve a universal health coverage. And my colleagues now are posting all the links to the chat. And at the same day, we have another webinar, Robots Saving Lives in Disaster Hit Areas. So we invite you to check out the links and register for the events you are interested in. And finally, join us on 1st of December at 5 o'clock for the webinar, AI in Weather and Climate, Doing Better, Doing Different, as part of the Discovery and AI and Climate series. And of course, if you are interested in the topic of AI and climate, we also invite you to learn more about the ITU focus group on environmental efficiency for artificial intelligence and other emerging technologies. And you can find the link right now in the chat. And with this, I would like to thank once again our speakers, our hosts, participants, partners, and sponsors, and of course, co-convener Switzerland. And I hope to see you next time. Thank you very much.
Selector, rewind selector, rewind selector, rewind selector, rewind selector, rewind selector. Selector, rewind selector, rewind selector, rewind selector.